it rises. So let's just leave this at that. Let's just leave this at that and increase the amount of time. Press enter, and this is gonna start generating. Okay, so let's wait for it to go to the 10,000 mark. Actually, I can just pop the X sensors here, and you can see that the cores are slowly beginning to warm up. 74 degrees on them is not something you want your processor to be on. Intel CPUs will basically tap out at 105 degrees Celsius. Your PC will shut down. So it shouldn't burn, it should actually shut down. But be careful with this. Be very careful. Like, always monitor the temperatures and make sure that you have good cooling. Let me just go ahead and show you another thing, which you can see while this is happening. You can type in htop, and this is the load on the CPU cores. Look, they're all being used 100%. And some of you might ask me, well, why don't you overclock them or something like that? They are overclocked. But it doesn't say here 110%, 120% or something like that. It just says that the full capacity of the allotted core time is used. You overclock these things in BIOS, and mine is overclocked from 3.5 to 3.9. So not a lot. I like to play it safe. There's no reason why I should accelerate this. But this is 10,000 keys per second. Remember that, and then we're going to see how many keys can actually a GPU generate. And we will use the hashcat. I'll show you how to install it. I'll show you how to install the proprietary NVIDIA drivers. You can also install the proprietary AMD drivers. It should work with them, no problems. There are plenty of guides out there, but I just can't use my AMD card now. There just is no way for me to use it. I don't know, AMD and NVIDIA on a Linux, once you put the two drivers in place, they don't really play well with one another at all. So I'm just going to go ahead and install the NVIDIA drivers from the gaming cards that I have in the PC, and then we'll see how that actually works and how many combinations do we get there. Because as it is now, we're getting about 10,000. So my processor is getting 10,000. Yours could be more or less. I don't know, depending on your processor type. If I go ahead and stop this, if I type in CPU info, cat proc CPU info, you can see the model of my processor here. It's i7-5960X, and its default clock rate is 3 gigahertz. So depending on your processor model, you might get more or less. Usually processors with a greater amount of threads will have significantly better performance here. But this is still CPU brute forcing. Once we get in the follow-up tutorial to the GPU brute forcing, this will change drastically. The number of combinations per a second will change drastically. It is also possible, by the way, to split the workload between multiple machines. What you would need to do is just generate password lists with Crunch and then just put them onto a USB and then go to each individual machine and just have it attempt to decode that particular set of passwords. Now here, this machine is, for example, 10,000, but you could go to another machine and that machine could be maybe 5,000, and another machine, and another machine, and another machine, and soon you get a larger number. That is very simple to do. It's not complicated at all. If you type in man crunch, you will even find a bit of a hidden example on how to do that. Down below you have examples. You need to find an example which actually splits the file sizes. Where is it? We'll generate bzip compressed files with each file containing 6,000 words. There you go. So the file names be first word list. Okay, so this will generate a compressed files with each file containing 6,000 words. So this command, and they will be zipped, so they'll be smaller. That's nice because you can take each file, and you can see the output down below. You can take each file, put it onto a USB, and go to a different PC, and have different PCs have a go at different portions of the hash of the password list. So one PC will, for example, take the first 6,000 words, the other one will take another 6,000, and another one will take 6,000. I mean, you obviously wouldn't put 6,000 here, you would put a lot bigger number, and every PC would have maybe, I don't know, 1,000,000 combinations to go over or more. And then you would be able to accelerate it. But it's still, it's a painful procedure. I don't want to show it here because I don't consider it to be particularly useful, as not, I'm guessing that not a lot of people have a lot of PCs just lying around that can work 24/7 around the clock to actually fix this. You could go renting on cloud, but then again, that costs money, and just to break a VPA2 password to pay like $10,000 for cloud, for this to work on a cloud, where the workload is split between thousands of machines, where you get like 2,000 cores or something like that, that would be pretty stupid in my opinion. But anyway, that is an option, of course. So with this